Hi everyone. So let us start implementing the merge sort method that we have just discussed. So we have this merge sort function that takes input a vector and start and end points of the vector that we need to sort, and we are going to complete this one. Okay. So let's see how we can do it. So first thing is we need to write a base case. Okay. Since it is a recursive method, you need to figure out what is the smallest possible array which will not require sorting. Okay, and here you will have the recursive case. So in the base case, you can say if start is greater than equal to end. That means we don't have any elements, or we just have one element that we need to sort. We can return, because array containing one element, we can assume this is a sorted array. In the recursive case, we will find out the midpoint. We can say start plus end by 2, and then we can say okay, merge sort on the left part of the array, that is array start and mid, and we can say merge sort on the right part of the array, that is array mid plus 1 and end. Okay, and once the left part and the right part are sorted, what do you need to do? You need to combine them into a single array. Okay, so you can say return merge array start and end. So we will write this function. As you can see here, we will write this function that merges two arrays into a single array. So as of now we are accepting a one array here, but let us assume we can break this array here and we will merge it. Okay, so what we discussed, let us say we have this entire array that is now divided into two parts about mid. Okay, so one part will start from mid plus 1 and another part will start from s, and this entire array is from s to e. So this is one part from start to mid, and from mid plus 1 to end, this is another part of the array, right? So we need to combine them into a new vector. You can say we will create a new temporary vector, and we will try to compare elements from these two parts, and we will try to fill this vector accordingly, right? So let me say we have a variable I that points to start, we have a variable mid that is s plus e by 2, and we have j that starts from mid plus 1. Okay, we have I here, we have j here. Okay, so we also create a temporary array, so vector of integers temp, and what we need to do, we need to say okay, while I is less than equal to m and j is less than equal to e. So while we have elements from both the parts to compare, we can compare them. So if array of I is less than array of j, then in the temporary vector I will push back the element from the first part of the array, that is array of I, and I can also do I plus plus. Otherwise I will push the element in the temporary vector from the second array, that is array of j, and I can increment the j pointer j plus plus. Okay, now this loop will break when one of these arrays is exhausted. Okay, maybe you have 2 4 6 here, and maybe you have 0 10 12 here. Okay, what will happen? So this, in the beginning you will have a 0 here, then you will put all the elements 2 4 6 from here, and this loop will be over because I has reached mid. Okay, so your I variable has reached mid, and you don't have any more elements in this array which you can compare with the remaining elements of this array. So what you need to do, you need to copy back the remaining elements directly. Okay, so there would be two cases. Either you can have remaining elements in the left array, or you can have remaining elements in the right array. So we will write code for both of them. Okay, so copy remaining elements from first array, or copy remaining elements from second array. Okay, or the second part. So let us say, so we can say while I is less than m, while I is less than equal to m, we can say temp dot pushback array of I, and we can do I plus plus, or we can copy from the second array. So while j is less than equals to end, we can say temp dot pushback array of j and j plus plus. Okay, so in any of the cases only one of these while loops will work. Okay, out of these two loops only one will execute, because one of the condition will automatically become false when this while loop stops. Okay, so finally we need to copy back the elements from temp to our original array, so that our merge sort function can see the actual changes. Okay, our merge sort function does not know anything about the temp array, so we need to copy back all the elements to the original array. So we are going to iterate from k equal to 0. Okay, so in the temp array the indexing will always start from 0, but in the original array the indexing will be from s to e. Okay, so maybe you make a recursive call on this part of the array. Okay, then this part is s, this part is e, it is not 0 to end. Okay, so we can say, okay, for int some index that is starting from s, index is less than equal to e, index plus plus, we can say in the original array, that is array, so we are passing this array by reference. Okay, so that the changes can get reflected. At array of index we can put temp of k, and in the temp array we can say the k starts from 0, because we are always creating a new temp array whenever this function is getting called. So, and we can say temp of k plus plus, so this k pointer also moves forward, and that's it. We can have the return statement here. Okay, so we have this thing as arr, and maybe this thing as arr. Now let us try to run our code and see the output, and you can see we are getting this array, which is now a sorted array, right? So that means our merge sort function is working perfectly fine, and also our merge function is also working fine, right? So it's little big, but you can say it's not difficult. So this is the entire merge function that we have, right? Now if you want, I can just dry run the code once more, and that will make the things more clear to you how recursion works in case of a merge sort. So let us dive little deep and see how the recursive solution works. So we have this array, we have 10 5 2 0 7 6 4. So you break this into two parts. So you create one part 10 5 2, and you make this call at line number 51. Okay, so line number 52 will not execute till this array is not sorted. So we again are in the merge sort function, a new merge sort function is called. You again break this into two parts. So you say, okay, let's say this is one part. Okay. So I think with the logic we have written, this will be one part and this will be another part. Okay, so we have 10 5 2 and 0. So we break this into two parts. We have 10 and 5, and 2 and 0 will be executed later on. Okay, so we again break this into two parts. We have 10 and we have 5. Now what happens? We say the start and end are equal, so we are in the base case and we return. So we just return these two elements. So when this merge sort is called, we break this into two parts, 10 and 5. Now what happens is we make a merge sort call on this part that hits the base case and we return. We make a merge sort call on this part that hits the base case and returns. So when we return in this particular function, right, so it was like this: merge sort with the array containing 7 elements, with the merge sort an array containing 4 elements. You create a merge sort call with an array containing 2 elements. You create a merge sort call with an array containing 1 element. This call returns back, and this call also returns back. Okay, so this call goes off. You again make this call for 5, and you are again back in this call. So now you have 2 elements and you already made these two calls, so you merge them. So when you merge them, you get this array 5 and 10. Okay, and this goes back. Okay, this goes back, So this part basically knows the left part has now been sorted, so you make a call on the right part to sort it. So you make a call here, so it becomes 2 and 0, and both of them return. And when you are coming back, you basically try to merge these two arrays, and you basically get 0 and 2. Okay, and once you get the left part and you get the right part, you are in this merge function in which you had a merge sort function in which you had 4 elements, and you have already sorted the left part and the right part. So what happens, this merge sort 4 function basically now calls the merge routine, and it tries to merge both of them. So you get 0, 2, 5 and 10. Now you are in this merge 7 function in which you have already sorted the left part of the array, and you make a call on the right part of the array. So this ms4 goes off and merge sort 3 is called. Okay, so where you have these 3 elements of the array that you need to sort. So you have 7, 6, 4. You again break them into 2 parts, 7 and 6, and you have a 4 here. And then you again break them into like 7 and 6, and they are merged like 6 and 7, and you know this part is now merged, the left part, and the right part is already sorted because you have one element, so this returns from the base case. And when you merge it with this part, it becomes 4, 6 and 7. Okay, and now you are again in the merge sort 7 function where you have the left part which is sorted, the right part which is sorted, and you merge them. So you have now 0, 2, 4, 5, 6, 7 and 10. So this is your final output, and this is now returned to the main method. Okay, so I just try to show you with the help of call stack and the entire recursion tree. The only thing you need to remember is recursion works in a depth first manner. Okay, so these calls don't happen parallelly. Once you go deep inside a branch, once that branch is finished, then you backtrack and you go in the another branch. Okay, so this is how the recursion works. Okay, so you go like this. So that's all for this video, and I hope you really understood the merge sort sorting algorithm. Thanks a lot.